So the height of the ball, it looks like it's given by s of t, which is, you can think of this just as s equals 30 minus 5t. T is in seconds. So if we plug in a time, it'll spit out the height of the ball above the ground. So what is the average velocity of the object on the interval from t equals 1 to the time 0.5 seconds later? In other words, what's the slope between t equals 1 and t equals 1.5? Because half a second later, from 1 second from the start, is 1.5 seconds. It's really just a slope problem. You got to find out what are the y coordinates, what are the heights that correspond to these time points. And that's real quick. If you plug in 1 in for t, 1 squared is 1. 1 times 5 is 5. 30 minus 5 makes 25. So s equals 25. And if you plug in 1.5, it's going to have some decimals. 1.5 times 1.5 times 5. So this term is minus 11.25. 30 minus 11.25 gives us 18.75 for the height half a second later. What was it? 18.75. Okay, so to find the average velocity from these two time points, it's y2 minus y1, the slope, the change in the y over the change in the x. So subtracting these two represents how much we're changing on the y-axis. And then subtracting the time intervals is how much we're changing on the x-axis. Just make sure, when you plug in those points, the x-coordinates and the y-coordinates, you get the corresponding coordinates on top of each other. y2 did the second point minus the first point. The second point minus the first point. Okay, when we compute that, 18.75 minus 25 divided by 1.5 minus 1 is 0.5. So negative 12.5. That's the average meters per second from those two time points. And now they want us to pick something even closer. So we're repeating the process. The two time intervals we have, the 2 time points we have is time t equals 1 and time t equals 1 second, 0.1 seconds later. So t equals 1.1. And we've already done this one. If you plug in 1 in for t, you get out 25 for s. And then if you plug in 1.1 in for t, I'll do that with my calculator. 1.1 needs to be squared first, then times 5, and then we take that result and subtract it from 30. So it's 23.95. So we're asked for the average velocity between those 2 points. That means we just need to subtract those two numbers. I did my second point first, so I got to make sure when I do my x coordinates, I do the second point first. So 23.95 minus 25, divide that by, we're going to have 0.1 in the denominator. That's negative 10.5 for our average velocity between those 2 points. We're asked to create a polynomial in terms of h, where h is like how many seconds later we are. Look, h in this case would be 0.5 because it was 0.5 seconds later from time t equals 1. And h in part B was 0.1, so we're talking about 1 plus h for the second time. Instead of like plugging in exact numbers, we're using a variable for the time away from t equals 1. Okay, and we're supposed to create a polynomial. Let's see. A polynomial for the average velocity. Remember, the average velocity is the slope, which we used to use as m a lot in our algebra courses. It's the slope, so it's s of t plus h minus s of t. Okay, the height at the new time, subtracted by the height at time t equals 1 is what we used to do. All over, here, this would be t plus h minus t. Right, the new time subtracted by the old time. Just like we were doing up here, now just with variables. But in order to write that out, s of t plus h, you got to plug t, and one more thing to make it a little easier. T equals 1. Our starting time period is at 1, so we can replace all those letter t's with number 1. So that makes our life easier. And so you've got to plug in 1 plus h in where you see a t into the height function. So we can have things in terms of the variables. So we have 30 minus, instead of t, I'm going to put 1 plus h. That gets squared. Subtract that by s of 1. Means the height when we plug in 1, which we've done a few times, we got 25 for that height, right? That's all over 1 plus h minus 1. If you do out the arithmetic there, 1 minus 1 makes 0, so you just have h in the denominator. If we keep simplifying, we can expand this. 1 plus h squared means we're taking a parentheses and multiplying it by itself. We've got 30 minus 5. And then if you do that off to the side on with pen and paper, 1 plus h in parentheses times 1 plus h, you should get 1 plus 2h plus h squared. Then minus 25. It's all being divided by h. And then still simplifying, we can distribute that negative 5 to everything inside the parentheses. I think I got it all. It's getting a little messier, but my hand gets tired of this thing. 30 minus 5 makes 25, and 25 minus 25 makes 0. So this is what we're left with when we combine those. And then you're dividing everything by h, so you can just cancel out an h in each term in the numerator. So it's negative 10 minus 5h. I guess that's what they're looking for here, okay? We used the slope. We plugged in the variables into the slope, and we rewrote and simplified. That's what the slope is. What does this average tend toward for h closer and closer to 0? So that means, h is how far away we are from time t equals 1. If as h goes to 0, the limit as h approaches 0 is negative 10, right? Because you could just plug in 0 into that expression when you evaluate that limit. What would you guess to be the exact velocity for the object after 1 second? Oh, at that instant, at t equals 1, we're guessing negative 10. I don't know what the difference is between those two, but